Okay, I think we should start. Transformations. There are various types of transformations. They are basically divided to two categories. There's isometric transformation and non-isometric. Previously, there used to be more transformations in non-isometric. What is isometric? Something that preserves shape and size. So the first isometric transformation that you have is translation. Then you have what you call reflection, and then you have rotation. And for isometric now does not preserve shape and or size. Okay, so you have enlargement here. There's just two types of transformations that you now need to study. Okay, what I'm going to do in class today is I'm going to describe one transformation every time, and I'm going to then take you through questions of that transformation. There may be parts that I keep switching between questions, and there may be other questions that I do in the middle, but let's try to grasp as much as we can using that. Okay, so a translation is just a movement along the X and Y axis. Okay. It is described using a translation vector. Okay. Translation vectors are described as AB, where A represents the movement on the x-axis and B represents movement on the y-axis. Okay. So start from object and move according to the vector. I think that translation is the simplest. I don't think anyone would have had trouble doing this. Let's see some questions that I have here for translation. The first one is this. It says triangle A is mapped onto triangle B by a translation of this. So it's 7 units in the positive X direction and -5 in the negative Y direction. Draw and label triangle B. So what I'm going to do is I'm going to start from this point and I'm going to start counting. 1, 2, 3, 4. I'm counting the number of boxes, not the number of dots that I'm making. I'm counting the number of boxes that I'm traveling. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, and 5. So that's the point that I have. Okay, so I mapped this point. Let's map the other point. If I go 7 units and I go 5 units, I end up here. So 7 and 5. I'm going to erase these lines because these bother me. And then you can sort of complete the shape or yourself as well rather than counting over and over again. This is your final answer then. You see the object and image are just the same shape and size. This is the object. Let's call this triangle B because the question is calling it triangle B, and this is the image. Okay, so nothing unusual about this. This is translations are generally simple. Let's see if we have another one. I'm going to do that for you. Okay, it's this one. It says rectangle R is mapped onto rectangle S by a translation of -2, 3. On the diagram, draw rectangle S. So -2 and 3. So I pick up this point, 1, -2, and 3 up, 1, 2, 3. So this point goes here. Okay. And then this point, 1, 2, 1, 2, 3. So this rectangle should look something like this. I'll call that rectangle S. It's moved -2 and 3. Okay. I hope there are no questions on this one. Let me see if we have another one. Okay, I don't think we have another one. Okay, and I think that's more than enough for describing a translation. I think everybody is generally comfortable with translations. If you have trouble, please ask, okay? Let's go on to the next one. The next one is called a reflection. Okay, reflection involves a line of reflection. Okay, the perpendicular distance between object between line of reflection and object is the same as the distance between image and line of reflection. Okay, let me just add on. Okay, object and image are on opposite sides of the line of reflection. Okay, does anyone know what orientation is not preserved? Does anybody know what orientation is? Sometimes it's important. It's not always important, but I want to show you how it's important. Let's label this A, B, C. If this is A, B, C, then this must be D, E, F. Okay. Now, whenever you're trying to figure out that if it's a reflection or not, you will see that on the object, you are circling like this, A, B, C. And on the image, then you're circling like that. This is important for a question later on, which is why I'm explaining to you right now. Okay. So the orientation has changed. You were going left and now you're going right in order to complete the letters of the shape. Okay, that's what I mean by orientation. Okay, let's look at a question on reflection. Let me show you something on reflection. This translation and enlargement. Okay, I have reflection here. Let's look at this. It says triangle B is mapped onto triangle C by a reflection in the y-axis. So I say reflection in the y-axis. This is my line of reflection. Now, it says on the triangle, draw triangle C. Now, what did I tell you? That the perpendicular distance between the line of reflection and the object is the same as the perpendicular distance on the other side. So I can say that this point is going to be reflected here. Similarly, this point is again 2 units away. It's going to be reflected here. You see, I'm moving perpendicularly. I'm always going to do that. Okay. and then this point comes up here because it's 4 units away. So you see the object has flipped over. It's triangle C. Triangle C has flipped over. Does everybody understand that? Okay, let me show you another one. I think I have very few on reflection. Okay, now this one. It says shape A is mapped onto shape B by a reflection. Write down the equation of the line of reflection. How do you find the equation of the line of reflection? In order to find the equation for the line of reflection. Now, this is something that you must have done in loci. Find the perpendicular bisector of the object image line. Object image line. Okay, so what I do is I draw an object image line. What does that mean? That I draw one point on the object and one point on the image and draw them using a straight line and join them using a straight line. Okay, then I try to find the perpendicular bisector. Now you must have done the perpendicular bisector. You place your compass at this point. You draw an arc like that. Then you place your compass at that point. You draw an arc like that. And then you draw a line through them that gives you the perpendicular bisector. Since I'm not teaching you loci, I'm going to draw it directly. I'm going to tell you that I can see that sometimes you can also see, so you can draw it directly if you want. This is my line of reflection. What line is this? This is the line y equals to -1. Horizontal lines have the equation y equals to k, y equals to c, and this line is crossing at -1, so y equals to -1. Okay. Now this is another question. You see they are flipped over, so it's a reflection. What is the line of reflection? The line of reflection looks like this. So I'm just going to say that it's a reflection in the x-axis. That's it. One mark for this and one mark for that. Pretty much that's it. Okay. Okay. Now, it says describe fully the single transformation that maps A onto B. A onto B. What do? I draw an object image line again. And I try to find the perpendicular bisector. This again looks something like this. So again, y equals to -1. Okay. Let me show you something else as well in this question. Let's say I told you that the line of reflection was this line. Okay. I don't know why this was not going through the points that I wanted it to go through, because I didn't draw it that way. Just an extra bit here. Okay, let's say I wanted to reflect triangle A. What would I do? I would travel perpendicularly like that, 1, 2, and 2.5, and then 1, 1/2, 1, and 2. So this point is going to come up here. Everybody understands the distance that I calculated? 1, 2, 2, 2.5. Okay, half, 1, and 2. So this point turns up here. Similarly, let's look at this point. Let's go perpendicularly. 1, 2, and 3. So 1, 2, and 3. This point comes up here. If I were to reflect this line, 1, 2, 3, 4, 5, 4.5, half, 1, 2, 3, 4. Okay. So what have I done in this question for you? I created a question where I was trying to reflect what line is this that I've drawn. The line that I've drawn for you is y equals to minus x. So you see I've reflected this in the line y equals to minus x. Okay, something that you should be able to do. It's just about traveling perpendicularly to the line of reflection. Okay, since this is not part of the question, I'm going to go ahead and erase it. You can see it back in the video if you want to. So I was trying to describe this triangle A onto triangle B. It's a reflection in the line y equals to minus 1. Okay. Now, the third type of transformation is a rotation, and I think most of you would be here for that. Most people find it tough. Let's look at rotation. Involves a center of rotation, an angle of rotation, and direction of rotation. Okay. How do I do rotation? Use vectors that start from the center of rotation. Travel to the object and note down your vector. Then use the following rules. Okay. So let's say I was first doing a 90-degree clockwise. Let's call this the object vector. And let's call that the image vector. Okay, let's say you counted the object vector as AB. And if you are doing a 90-degree clockwise rotation, this becomes B and minus A. Okay, the numbers swap themselves and the number at the bottom becomes negative. I'm going to do these transformations for you. I'm just writing down the number, the vectors first. I don't know if you've done them this way because there are various ways to teach. Okay, and 180 degrees. Oh, sorry. Okay, let's look at how to apply this. Okay, now this is triangle. Well, let me show you something with the 90 degrees. That's going to be easier for me to explain. Okay, let's look at this one. It says shape A is mapped onto shape C by a rotation 90 degrees clockwise, center 1, 0. Let me mark my center first. So I marked my center. Draw and label the shape C. Now I know that when I'm doing 90 degrees clockwise transformations, 90 degrees clockwise है ना, क्या rule होता है, पहले मैं rule अपना लिख लूं कि AB becomes B minus A. Okay, AB becomes B minus A. So let me just note down the rule there only so that we're not confused at the end. So AB becomes B and minus A. Okay, that's what it's becoming. Now, how do you apply this? You start from your center of rotation. Let's say you pick up this object first. How much are you traveling? 1, 2, 1, 2, 3. So you'll say that your object vector is 2, 3. 2 and 3. What is this going to become? It's going to become 3 and minus 2 according to the numbers that I've given you, according to the rules that I've given you. So what you do is, in order to plot this image, you start with 1, you start again and you say 1, 2, 3, and you go down and you reach this point. So you map one object and image. This is 90 degrees. Clockwise rotation. Just give me a moment, 1 minute. Okay, then I pick up another object. मैं इसको erase कर देता हूँ. मैंने कहा कि ये वाला point तो transform हो गया. Let's erase that. Let's start again from the center of rotation. Let's pick up this point. 1 and 2. So I say 1 and 2. That should become 2 and minus 1. So 2 and minus 1. 1, 2 and minus 1. This point comes up here. Okay. I erase this again. Okay. Then I have this point. So it's 0 and 2. 0 and 2 becomes what? 2 and minus 0. Minus 0 is nothing. So just 2. This point comes up here. Okay. And then this is 3 and 0. So 0 and 3, sorry, and 3 and 0 ho gaya. So this shape comes up like that. We just erase the dots and over here. Let me just join them with the blue line. Okay, does everybody understand how I applied the rules? You need to remember the rules if you want to do these transformations correctly and quickly. It's just about remembering the vectors. Okay, so AB becomes B minus A in a 90 degrees clockwise rotation with center 1, 0. I've mapped it. Any questions? You may have done it differently in school. There are various ways of teaching rotation. This is what I feel comfortable teaching. Okay. Okay, let's look at another one that said 180 degrees about the point 2 comma minus 1. Let me just first mark the point 2 comma minus 1. What was the rule for 180 degrees? It was AB becomes minus A minus B. Okay, so I'll start counting this one and I'm going to say that this distance is minus 1 and 2. So it's going to become 1 and minus 2. So 1 and minus 2. Okay. So this point comes up here. I'm going to erase the rest of the lines. Okay. The next point with a different color. Let's look at this one. 1, minus 1, and 1, 2, 3, and 4. So minus 1 and 4 becomes 1 and minus 4. So 1 and minus 4. Okay. And then this is just 0 and 2. So this becomes 0 and minus 2. Okay. Just draw this again. Makes sense? Any questions in the way that I'm doing this rotation? No? Okay. Uh, there are questions about finding the center of rotation as well. We're going to talk about it in a bit. Abhi thodi der baad I'll come across questions. Let me first show you enlargement. Okay. Involves what? Involves a center of enlargement and scale factor. Okay, something about the scale factor. Scale factor is positive when object and image are on the same side. Same side of what? Same side of center of enlargement. It is negative when they are on opposite sides. Now again, I'm going to use vectors to do this again. How to do it? Start from the center of enlargement. Start from center and travel to object. So yeah, note down the vector. Multiply this vector with the scale factor for the image vector. Okay, let's see. So scale factor formula kya hota hai? Scale factor can be found using two ways. I can say that it is length of image over length of object. Or it can also be distance between center of enlargement and object and image, sorry, divided by distance between. Talal, can you mute yourself, please? Okay. Okay, let's see how it's done. कहीं question draw करने का हो मैं पहले वो दिखाता हूँ फिर मैं आपको matrices वगैरह पे लेके जाऊँगा. Okay, this says triangle A is mapped onto triangle C by an enlargement of scale factor -2 and center -1,2. So the first thing that I should do is I should mark my center of enlargement -1,2. -1,2. Oh, that's my center of enlargement. Okay, let's put a round around that. Then what I'm going to do is I'm going to again start noting down my vectors. The first one is -1, -1. So what does -1, -1 become? What is my scale factor? It's -2. So if I multiply these by -2, I get 2 and 2. So the next movement I'm going to draw is 2 and 2. So 1, 2, 1, 2. I reach this point. Let's count the next one. -1, -2, and -1. So -2 and -1. That gives me what? 4 and 2. I'm multiplying this by -2. All of these by -2. Okay. So 4 and 2. Let's go on to 4 and 2. 1, 2, 3, 4, 1, 2. Each here. Okay. Then -1, -2, 1 and 2. -2 and 2. So this becomes what? This becomes 4 and -4. So 4 and -4. 1, 2, 3, 4. 1, 2, 3, 4. Okay. Okay. That is my enlargement. What's this? This is triangle C. Any questions? Let's look at another one. These are about matrices, and I don't want to focus on matrices right now, but let me just show you another enlargement if I can possibly here first, and then okay, this was a transformation that I should have reflection में कर लेता हूँ reflect, but let's do that tomorrow again. Okay, I have no other enlargement where I need to do the enlargement, but I have something that I need to figure out. Okay. Describe fully the transformation that maps triangle A onto triangle C. So I'm going to do this triangle A onto triangle C. I can obviously see that this is an enlargement. How to find the center of enlargement? In order to find the center of enlargement, draw two corresponding object image lines and see where they intersect. सही है. अगर मुझे enlargement को describe करना है तो मुझे center of enlargement भी बताना पड़ेगा and मुझे जो है वो scale factor भी बताना पड़ेगा. अब corresponding. So this point corresponds to this point. So I'm going to join these with a straight line. That's one object image line. Similarly, this one corresponds to this one. So I'm going to join these with a straight line. Where do they intersect? They intersect at this point. What is this point? This point is -3, 2. So I'm going to say that this is an enlargement. Center minus 3 2. Okay, let's talk about the scale factor. I wrote down the formulas for the scale factor. I said length of object over length of image. Let's talk about the, sorry, length of image over the length of object. Image of object. Okay, let's talk about the longest length. Can I say that the longest length here was 2? So the denominator is 2, object is 2. What about the image? 1, 2, 3, 4, 5, 6, and I'm traveling in the opposite direction. So I'm going to say minus 6. That gives me minus 3. So I'm going to say that this is an enlargement with center this and scale factor minus 3. Okay, do we all understand this? See, transformations are not that difficult. Okay, we left out transformation matrices yesterday, and let me first tell you the transformation matrix equation that you use to find unknown images. It's always transformation matrix into object matrix equals to image matrix. Okay, and using an example, I'm going to tell you how to do that. Let's see the first question. It says triangle A is mapped onto triangle C by a transformation represented by the matrix this. Now, if you don't know what this matrix is, I know that it's an enlargement because I see 3 in this and so on. What I would do is I would use my equation. I'd say that transformation matrix into the object matrix. Now, how to write the object matrix? Write down the coordinates first. 1, 1, 2, 1, and 1, 3. So 1, 1, 2, 1, and 1, 3. Okay, and what I will do is I will do a multiplication for the matrices. Now, I am assuming that most of you know what this multiplication is. It's always rows into columns. So 3 into 1 plus 1 into 0, that gives me the first row and first column. Then I use the first row and I use the second column. So 3 into 2 plus 0 into 1. Then the first row and the third column. So 3 into 1 plus 0 into 3. Then 0 into 1 plus 3 into 1 plus 0 into 2 plus 3 into 1 plus 0 into 1 plus 3 into 3. What does that, all of that give me? It gives me 3 on the first one, 3 below it, then 6 here and 3 here, and then 3 here and 9 here. And I'm going to go and plot that. 3 3, 6 3, and 3 9. So you see it has been enlarged. I could see that I was supposed to multiply by 3, which is why this is enlarged. If I ask you to describe this enlargement, you tell me that this is scale factor 3, and the center, whenever I'm talking about matrices, the center is always 0, 0. Remember that. Whenever we're talking about matrices, the center is always 0, 0. Okay. Then it says write down the matrix that represents the transformation that maps triangle C onto triangle A. Now, what maps triangle C back to triangle A? Okay. Whenever you, now I know that I must shrink this. How would I shrink this? By saying that the scale factor is 1/3. So I'm going to just copy the matrix from above and say that this becomes, instead of that, it becomes 1/3, 0, and 1/3. This is a simple question. I'm going to tell you how to construct matrices later on. Okay. Then it says describe fully the single transformation that maps triangle C onto triangle B. Triangle C onto triangle B. Let's look at that. Now, triangle C onto triangle B is also an enlargement. I need two things. I need the scale factor and I need the center of enlargement. Yesterday I told you that in order to find the center of enlargement, you join an object and its image and the object and the image. Okay. This looks like the center of enlargement is basically, it's not a whole number in this case. That's a little surprising. 3 comma minus 1.5. So center 3 comma minus 1.5. And C is the object and B is the image. So length of image is 1 and length of object is minus 3. So I'm going to say that scale factor is 1 over minus 3, which is minus 1/3. And I have to say that this is an enlargement. Okay, does that make sense? Any questions? Okay, the second part is vectors. Let's just leave that right now. Okay, we've done this question completely. There's a matrix left in this question. Let's talk about that. It says triangle A is mapped onto triangle B by a single transformation K. Find the matrix representing the transformation. Okay, so what does A and B look like? This looks like a rotation to me. Okay. Okay. Whenever I ask you to construct a matrix, the center always has to be 0, 0. So if I were to plot this 0, 0, I would see that this is basically a 90-degree anti-clockwise transformation. Okay. Now here I'm telling you how to construct matrices. Whenever you're constructing matrices, you talk about these 2 points, A, which is 1, 0, and B, which is 0, 1. If I were to take these 2 points and apply this 90-degree anti-clockwise transformation about the center 0, 0 on it, this point would move here 90 degrees. Sorry, is this 90 degrees anti-clockwise? Sorry, 90 degrees anti-clockwise. Okay, 90 degrees anti-clockwise. So this point would go here. So I can say that A dash would become 0, 1 and B dash would become minus 1, 0. So whenever you're constructing matrices, you need to write down A dash and B dash. That is the matrix that represents the transformation 90 degrees anti-clockwise about the center 0, 0. Okay, remember that whenever I ask you to construct matrices, the center will always be 0, 0. Okay. Then it says that triangle A is mapped onto triangle C by a single transformation L. Triangle A and triangle C. Do you see the relationship? I think it's a reflection. I think it's a reflection because I see it flipping over. It's flipped over. Okay, this is flipping over. What line do I think I'm going to draw? If you want to find the line of reflection, in order to find the line of reflection, let me write that down here. In order to find the line of reflection, draw the perpendicular bisector of the object image line. So I've drawn this using a compass and a scale. If a compass and a pencil, if I were to draw the perpendicular bisector, it would look something like this. So it would look something like this. Okay. So this line is basically y equals to x. So yeah, I've drawn, since I could see it directly, I've written it directly. Reflection in the line, y equals to x. Is all of this making sense? I hope it is. If you have trouble, please ask. Okay. It says transformation P is represented by the matrix this. P maps A onto B. Draw and label the triangle B. Now, can you look at it directly and sort of see that this is basically an enlargement? Center 0, 0. What do you think is the scale factor? Scale factor is -2. But I'm going to use my formula. I'm going to say that -2, 0 object matrix, transformation matrix into the object matrix. 2, 1, 3, 1, 2, 3. 2, 1, 3, 1, 2, 3. Okay, and I'm going to multiply it. Okay, that's the multiplication I have. I get -4, -2, -6, -2, -4, and -6. -4 and -2 gives me here -6 and -2. Okay, sorry, -4 and -2 is here. -6 and -2 is here. And -4 and -6. That's here. You see, it's an enlargement. Since the scale factor was negative, I can imagine that the center is between this and this, so that's the center. So whenever you have a matrix, the center has to be 0, 0. Otherwise, the matrix cannot be constructed. Okay, then it says describe fully the single transformation P. P. So how do I describe it? I've just described it for you. Enlargement. Center 0, 0. Scale factor -2. Write down the ratio of A and B. If the lengths are in the ratio 1:2, then the area must be in the ratio 1 square is to 2 square. This comes from similar triangles, so 1:4. Okay. Okay, then it says transformation Q is represented by this matrix. Now this is often difficult to see कि कौन सी transformation है, because this could either be reflection or rotation or something like that. Q maps triangle B onto triangle C. Draw and label the triangle C. So what I'm going to do is I'm going to use my formula. I'm going to say that the transformation matrix multiplied by the object matrix. In this case, the object is B. Let me just write down. I have the coordinates, in fact. -4, -2, -6, -2, and -4, -6. Okay, I'm going to multiply them. 1 into minus 4 plus 0 into minus 2, 0 into minus 4 plus minus 1 into minus 2, 1 into minus 6 plus 0 into minus 2, 0 into minus 6 plus minus 1 into 2, minus 2, 1 into minus 4 plus 0 into minus 6, 0 into minus 4 plus minus 1 into minus 6, minus 4, 2, minus 6, 2, and minus 4, 6. Okay. Draw and label triangle C, minus 4 and 2. So minus 4 and 2. Here, minus 6 and 2. So I think this is a reflection. Any questions? No. Okay. I left out this part. Let's talk about this part and then we'll move on. Let's see how many are left. Okay, this is shape A and B are shown on the grid. Describe fully the enlargement. If it's telling you that it's an enlargement, okay? So I don't need to worry about finding what it is. I know that it's an enlargement. So what I do is I join my object and images and see what happens. I have to draw it here as well. Okay. And so this one. I think this is let me just do this again. Okay. I think that's the point. 7, 1. Okay. Then the length of object over the length of image. This is 2 units. This is 1 unit. So I can say that this enlargement has center 7, 1 and scale factor 2. 2 over 1 is 2. Okay, then it says transformation P represented by the matrices P maps A onto D. Draw and label the triangle D. So I'm going to do my multiplication. A onto D. A के coordinates चाहिए मुझे. So I have 4 coordinates to look forward to. 1, 2, 2, 2, 3, 3, 2, 2, 2, 3, 3. Okay, then I'm going to start multiplying. 0 into 1 plus minus 1 into 2. 0 into 2 plus minus 1 into 2. That gives me -2, that gives me -1, that gives me -2, that gives me -2. Then it gives me -3, and that also gives me -3. That gives me -4. So -2 and -1. -2 and -1. -2, -2, -3, -3. -2, -2, -3, -3. And -3 and -4. That's a calculation mistake. -3 and -4. Some calculation mistake. Let me check again. Okay, can I check the working again? -2, -2, -3, -3, -1, -2, -3. Have I written the coordinates correctly? Oh, this is not 4, 3. This is 1, 3. This is why it's messing up. This is supposed to be -1. No, it's fine. Okay, so these are the 4 points that come up. Okay, can we describe this transformation? What do you think this is? This looks like a rotation to me. Okay, or a reflection. What do you think this is? Anyone? This looks like a reflection to me. See, I can draw a line of reflection because the shape is flipped over. What is this line? This line is y equals to x. Okay, honestly, I didn't have to, I have to describe it in the next part. So I'm going to say that this is a reflection in the line y equals to x. Okay. Okay, same question. I can do this. I don't think it's necessary. It's become repetitive. Can you tell me what this might be? What sort of a transformation might this be? Anyone? This is by looking at the matrix. When do these numbers change? When are they not 1 and -1? When it's an enlargement. I told you that the center is always 0, 0, and the scale factor is 2. I can draw this transformation for you, but it's going to give me the same sort of answer. I can show you this transformation. If I were to multiply and get coordinates, they would look like this. 2, 2, and 2, 2, 4, 4, and 4, 1 is 8, 2. That would be your shape. That would be D if I were to draw it. Okay. Now this is one last thing that I want to do. That it brings me to the end of the paper as well. It says triangle A is mapped onto triangle C by a single transformation H. Find the matrix representing H. Whenever I'm asking you to find the matrix, I told you that the center must always be 0, 0. This looks like a rotation to me. You see this triangle has been rotated. Let's see how much it has been rotated. This looks like it's 90 degrees and it's going like that. So it's going anti-clockwise. So 90 degrees anti-clockwise. About 0, 0. I just told you how to construct matrices. You take these two points and do the necessary transformation on these 2 points. Okay. B dash and A dash. Okay. So A dash and B dash, I write down on that. Now, this is what we call a combined transformation. What is happening in this case is that the transformation M is applying on A first, and then there's an R that is the second transformation, that is on the result. Let's first do M. M is a reflection in the line x equals to 2. So what am I going to draw? I'm going to draw the line x equals to 2 for you. X equals to 2 is this line. Let's reflect. This point comes here. There's another point here, and there's another point here. That's the reflection. Okay. Now this is just intermediate drawing. I still need to do this R on this. It's a 180-degree rotation. We learned how to do 180-degree rotations. We said, okay, you measure the vector, and the vector becomes this. When it's 180 degrees, I've written down somewhere. Then you take this point, you transform it. Okay, that's one point that I've marked. Then you look at this point. It's 0, 5. So this becomes minus 0, minus 5. Comes up here. This is 1, 2. 1, 2 should become minus 1, minus 2. So minus 1 and minus 2. So that's a 180-degree rotation. So this is my final answer. I should label this one D. I can get rid of the other one. I can say that this was not required. Okay, but I'm just going to keep it there so that it's there in the calculations. Okay.